So in this video, I'm going to talk about the derivative of the exponential function e to the x. So hopefully you've seen this function, the exponential function e to the x, the graph of it looks like this, where the one main point we know is that this point is 0, 1, and e by itself is a constant. It's kind of like the number pi. It's an irrational number that goes on forever. It's like 2.71 and then it goes on forever, but that's the value of e. But for the derivative of e to the x, it's actually one of the easiest ones. The derivative of e to the x is just itself e to the x. So the proof of it is kind of beyond this class, but if I show you the graph, like y1, e to the x is there, and if I take the derivative of e to the x, so remember d dx means the derivative. If I graph both of them on the same graph, and I want it to actually show you, so let me do this again. Okay, notice it's just tracing it. And so the derivative of e to the x is just itself e to the x. So it's one of the easiest ones to know. And the other main derivative in this section is the derivative of the function y equals ln of x. So again, the proof is kind of beyond this class. But if I graph ln of x, and then in y2 I do the derivative, okay, so that's ln of x, and this graph here is a graph of a function that hopefully, well, it's only part of the function we recognize, but what happens is the graph of the derivative of ln of x, which looks like this, gives me this function, and this function is the graph of y equals 1 over x for x is greater than 0. Because the domain of ln of x is greater than 0, so the domain of the derivative has to be the same. So when I have ln of x, the derivative of it is always 1 over x. So that's another derivative you have to know and memorize. So these are two new derivatives, kind of special cases. So the derivative of ln of x is 1 over x, and the derivative of e to the x is e to the x. So those are the two kind of new special derivatives. So again, just to reiterate, the derivative of e to the x is itself e to the x. And then the derivative of the function ln of x is 1 over x. Okay, and again, the domain for these is always just x is greater than 0. So hopefully that helps with finding the derivative in this section. Let me know if you have any questions on it.